Hi, welcome back to my channel. Today we can talk about the RDBMS transaction management by implementing with an application. So the tools and technologies which I am going to use here is Java Spring Transaction Hibernate Adapter, which is supporting the JPA. So which is integrated with the Spring JPA, Java Persistence Transaction API. Okay. So let's understand some of the basics about what is RDBMS engine and what is concurrency, all those things. So as I said, I'm going to develop a simple application and I'll try to withdraw money concurrently on the multi-threaded approach. Say that three concurrent operations operating on the same account number. So one of the transaction would success, the remaining two transactions will fail. So I need to design and develop by integrating these different components like RDBMS engine, transaction management with respect to the application by supporting the transactions. How do I do it? So I'm building a simple Java with microservices based application. So microservices implementation, I'm using Spring Boot. I'm integrating Spring Transaction API with Hibernate Adapter. And I'm also building a simple REST service that is a HTTP call, calling a multi-threaded operation and record the transaction whether it is successful or failure. Whatever the state is, I'm just printing on the console, even whether it is successful or on the failure case, I'm recording it. Okay, so that's the goal of this use case. Let's understand the RDBMS principles. So, relational database management system is basically a OLTP system, online transaction system. That means whatever operation which we perform, whether it is successful or failure, that's the basic fundamental. So it supports ACID compliant. ACID is an acronym which stands for atomicity, consistency, isolation, and durability. So that means, so this engine supports some compliant, which is a standard to operate. That is how evolved the database management system. So what is mean by atomicity? All the changes, whatever which is happening in that particular transaction. Transaction is again nothing but a unit of work that should be either committed successfully or rolled back in case of failure. That is called atomicity. And then consistency. The state of the data system moves from valid state to another from the beginning of the transaction to its completion. Let us take a simple example. Say I am withdrawing $50 from my bank account. Say that my bank account has $500. At the same time, my brother also is withdrawing $100 on the same account. So let us consider this is a hypothetical scenario. What happens when I withdraw $50? I supposed to see 450 remaining balance. When my brother withdraws $100, he is supposed to see $400. Is this correct? Ideally, no, because two transactions are happening here. So we need to see that how effectively manage the balance at the account side. So whether two transactions should be successful or one should be successful or two should be failed depends on the nature of the application. So how do we design and implement that matters. So the goal is we're supposed to see, say two transactions successful, we're supposed to see the remaining balance $350. Or one transaction successful, other one failed. Say my brother transaction successful, he's supposed to see 400, my transaction is failed. Or my transaction successful, my brother transaction failed, I should see 450 remaining balance. This is how we should manage and maintain a consistency of the data. Isolation. What does mean by right now, as I said, described as consistency. So we both operating from two different locations. We don't know what I am doing each other, what he is doing on the same account. So that is called effects of one transaction is not visible to another transaction until the transaction completes it. That is how do you segregate your transaction scopes when dealing with the RDBMS engine and durability. Once the transaction, the unit of work successful, you need to make that as a permanent data into your RDBMS engine on a specific table. You create table, database, schema, and table, blah blah. That follows the legacy fundamentals of the. And also people call it as a verb CRUD acronym. That means creating a record, reading a record, updating a record, and deleting a record. So these are the basic terminology. We must know it. So now let us understand how isolation concurrently performs when it is being effectively used in the enterprise level applications. So basically RDBMS is shared across different applications. So when it is being shared resource, how these transactions are effectively handled. Say one of the transaction is reading, at the same time another transaction will be reading, sorry, updating the data. How are we going to handle it? So there could be three different scenarios could occur: dirty reads, non-repeatable reads, and phantom reads. What is mean by dirty reads? Occur when data that has been updated in a transaction and not yet committed is read by another transaction. So dirty read could occur. Non-repeatable reads could occur when a transaction reads data, a second transaction subsequently updates the data, and the first transaction reads the data again after successful of the second transaction's update. So that means every scenario here we have to carefully consider and implement during the application code writing. And phantom reads. Phantom reads something which is going to be happening in a range. Say I am going to query a range. In that range, there could be changes made. So how effectively I can see the consistency of the data, even though two people are doing two different invisible operations. That's where the JDBC, Java Database Connectivity API, has defined a set of isolation levels. Transaction none. There are no transactions are being applied. Transaction read uncommitted. That means all the three states of the above, dirty reads, non-repeatable reads, phantom reads, could occur. And transaction read committed, that is another isolation type of attribute which says that dirty reads are prevented, non-repeatable reads and phantom reads could occur. And repeatable read, here dirty reads and non-repeatable reads prevented, but phantom read still can happen. If I wanted to make sure completely my data is consistent across my transactions, so I have to go ahead and apply a transaction serializable which will log the entire row. I can prevent all the three attributes of the dirty reading of the data. Okay. So this is how it has been defined. Let us consider that when we are building an application, so we will develop application program, and also we will use the resource managers. Resource manager is nothing but a database management resources. So that means the JDBC, connection attributes, URLs, usernames, properties, database, schema, table. So these are all belong to the database resources. So first application uses the resource management details establishing a connection. And then the same application program makes a call to a transaction manager. Transaction manager, which is responsible, another program to communicate with the resource manager and make the changes as per the code written by the application programmer. So it builds the boundaries, what action to be performed depends on the isolation and transaction propagations which we are specifying in our application management system. So Spring comes up with different types of propagations. Transaction propagations are required. That means if there is any existing transaction, use it. Otherwise, create a one. Requires new. Discard the existing transaction. You create a new transaction. Supports. If it is existing transaction use it. Otherwise, create a new one. Not supported. That means it will transaction will not support. Mandatory. There should be must be existing transaction to perform mandatory, and it never it never applies a transaction. Those are the transaction management propagations also defined by Spring, like how isolation was defined by JDBC transaction, because application management team is responsible to handle all these transaction related. So here I'm using a simple architecture. I'm building a simple REST API which is running on the localhost 10,000 port, and Spring transaction by integrating the Hibernate adapter, and the database engine is DB2 server, DB server. Sorry, not DB2, DB server. Database server is H2 engine, which is running on the 48 port. So let's understand what are the prerequisites required. So JDK 8 or more version and H2 database server, IntelliJ, blah blah blah. This you can understand. So these are the help URLs. You can more go through about ACID compliant and other things. So to understand the Spring transaction, the code is available in the GitHub. Thanks. Let's go back to the source code and try to understand. Yeah. Now I have source code ready available in my local workbench. Definitely you can go ahead and check out, and you can refer readme.md for further details. So I'll explain here what I'm doing is. So I'm creating a database server, that is H2 engine. I'm bringing up as a server mode, and I'm creating a table. The table has very simple. This is the table structure, and I'm inserting some basic information during the successful phase of the database engine. So I'm running a database management server. So I wrongly clicked on the Spring Boot application. So I supposed to do it by clicking the database server. Otherwise, you can come here, right click, run. You don't need to do anything further. Only thing is you're supposed to configure a specific path in your local drive, that instruction already given in the readme file. So here you will get a database file created for the H2 server. And now that will give you a beautiful UI console, something like this. So let's go ahead and refresh and use welcome one is the password. It is also available in the run server, and here there is a account table created. Now I will see that okay, 3 accounts are there and some amount is available, and now my database server is up and running. Now let me bring up my application server, that is Spring Boot. Either you can come here and do a right click. If it is a fresh, I have already ran here, so I have seen it available under here. So that is the reason I'm coming and starting up here. Meantime, let's understand. So here I'm using app config. This is the one which I was referring, establishing a remote database server. In case if it is hosted in a different network, of course I can use that and I can call it and get the remote details of the database, and I can have in my configuration. So I'm using Jaxer is a framework. Hikari config, I use it and configure set of minimum ideal connections, whole size 10 connections, auto commit I'm turning off, and I'm specifying to the database engine that it should have a read committed isolation level to my database engine, and then I create the Hibernate transaction JPA mechanism. So I was talking that Hibernate is the adapter vendor I'm using it. So Hibernate JPA vendor, you can see these are all self-explanatory. This will give you realistic information how I configured, and I have an entity model which defined it in this Com Narayana JPA model. So let's see what is this model. And before go to the model, let's see the transaction management. I'm also implementing a platform transaction manager, which is inherited by JPA transaction manager. I am specifying the entity manager factory to perform the unit of the transaction of all of our operations. And here I am having another configuration object which is responsible for the enabling the JPA repository where my JPA object is. So this is a JPA repository. Now let's go to the model object. So model object, it is an entity model. So I have a entity and table mapping with that, and identifier, account number, account holder, amount, and this is version. So if any transaction is performing, this version keep getting updated to have the optimistic locking. And now let's go to the account repository. Account repository is a simple interface which is a repository type of the JPA. So you can see that it is where it was inherited from. So it is a JPA repository. So you can see all the dependencies from your pom.xml. So pom.xml, which will give you what library is being used in this application. So which is inheriting the JPA repository by passing the account and serializable. Serializable is a I can use as a generic way for the identifiers rather than customizing my own identifiers. And I have a simple service. So this is where I was referring to the transaction management. So here, if you look at a lot of transaction related stereotypes, annotations, which is a declarative statements which I'm inheriting from the Spring Transaction Management. So propagation, isolation, transactional, these are all the things which supported from the Spring transaction. I'm making that my service is a transactional object, and it supports always a read transactions and ensures that if there is transaction is available, use it, otherwise create a new transaction. That's how this works, the propagation. And I'm specifying here the isolation as described in the PPT. So isolation as serializable. I don't want to see any dirty things in my application when I'm performing. So at the object level I'm specifying, but let us go ahead and see withdraw operation, and I'm initiating the repository and all blah blah blah. Now let's understand, this is my operation withdraw. This withdraw has again a transactional scope. So what it is mean by that means I'm saying that discard any existing transaction. I wanted to start a fresh transaction on this operation. That means because I'm going to perform some calculations which is important to my application, whether I should perform completely successful or failure it. That is why I'm specifying here requires new, and isolation I'm specifying read committed. That means I am preventing the dirty reads, and I am okay with non-repeatable reads and phantom reads when it is being happening. So I send the account number and I send the amount to withdraw, and I make a call to the database whether the customer is existing or not. If yes, if it is existing, then I get the amount and I see that old amount, I get the new amount, and then I perform a balance check whether it is a negative or not to perform transaction. If it is not negative, then I update the balance to the new balance, and then I update into my transaction table using entity. Say, as I said, we are performing 3 transactions concurrently using a multi-threaded operation. So let us now come to the rest endpoint. So I have a call multi-thread is the name of the operation, and here I'm implementing a scheduler framework which supports, and then the same account number, $10 withdraw, $20 withdraw, $30 withdraw. I'm making a call to, I'm using Java 8 parallel streams, and I'm mapping call map parallel. So here it will come and make a call to a thread task, that is withdraw task, which is returning a callback, that is a callable statement I'm using because to get some written data task that I call it as, and then I submit. Now hex contains 3. All 3 objects will be submitted parallelly. Okay, and one of them gets successful, the remaining 2 gets failed. You can definitely see those statuses. So this is how your transaction objects are effectively handled through service implementation layer. So service implementation layer, which is the one effectively handle carefully the transaction management system. How do you want to enable it? Now let me go ahead and call a multi-threaded operation. So now I'm doing it. I see a message true, but in reality, if I go back to the database, if I rerun my query, that means the same account number, I submitted 3 concurrent calls, 2 failed, 1 successful. That is, the $20 one was successful, the remaining 2 transactions are failed. So you can see it is coming. I mean, I have not handled here all the variety of exceptions. If you would like, definitely you can go ahead and implement those changes at your side. You can see that stale objects state exception. That means here it is being performed optimistic locking. For stale kind of a data, if it is there is a change by one transaction, the other transaction is trying to modify, which was incorrect. That's why you see this exception, and I specified isolation is read committed. So that's the reason you get that kind of a error, and all the logs are printed on the console. You can definitely go ahead and see how this is effectively handle the transaction. Okay, so definitely you can try. I believe you can enhance further this simple application. If you are interested, please subscribe and like it. Thank you.